Inland fisheries provides a vital source of commerce, employment, nutrition, and recreation for people throughout the world, particularly in subsistence and artisanal inland fisheries, where fisheries constitute a safety net for millions of rural poor people by providing an essential source of food and supplemental income. Inland fisheries sector has the mainstay in fish production in India, and the status is likely to continue in the future as well. Although the major chunk of this production is projected from aquaculture, increase in fish production from inland capture is also anticipated in a big way. Considering constant decline in fish catch from rivers over the years, measures are necessary for efficient and generous utilization of river-associated systems for enhancing fish production, productivity, and livelihoods for inland fishes. Reservoirs are ubiquitous man-made lakes that dot the Indian subcontinent, covering 1% of the land surface. Although created primarily for irrigation, power generation, and other water development purposes, these water bodies have become prime inland fisheries resources for the country. Considering their enormous size, that is 3.15 million hectares, reservoirs have attracted the focus for inland fisheries development in the country. The sheer magnitude of the resource make it possible to enable a substantial increase in production by even a modest improvement in the yield. The benefit of increased yield and income generated from reservoirs is more equitably distributed among fishing community. There is also a need to dovetail the twin objectives of yield optimization and environmental conservation. Taking these facts, Indian Council of Agriculture Research, Central Inland Fisheries Research Institute, ICAR-CIFRI, the pioneering research institute in India, has developed technologies for sustainable fish production from reservoirs. Fisheries enhancements can be achieved through human interventions, such as stock enhancement, that is, increasing the stock, species enhancement, that is, inducting new species to broaden the catch structure, and environmental enhancement, that is, enriching the water quality through artificial eutrophication, and also enhancement through enclosure cultures like cage culture, pen culture, and fish aggregating devices. Cage culture is an aquaculture production system where fishes are held in floating net enclosures. Fishes can be reared from fry to fingerling, fingerling to table size, or table size to marketable size, while captive in an enclosed space that maintains the free exchange of water with the surrounding water body. Cages are generally small in freshwater reservoirs ranging from 1 square meter to 500 square meter. Several cages combined in a battery is best suited for intensive culture. Though 22 billion fish fry are produced every year in India, there is acute shortage of fingerlings for stocking in reservoirs. And where fingerlings are available, transporting them to reservoirs usually incurs high mortality. In this context, producing fingerlings in cages offers opportunity for supplying stocking material, which are vital inputs for enhancing fish production. Cage culture has some distinctive advantages, like many types of water resources can be used, including lakes, reservoirs, ponds, streams, and rivers. Low capital cost is required. Observation and sampling of fishes is simple, hence only minimum supervision is needed. high stocking rate, reduced mortality, better control of fish population, efficient control of competitors and predators, use of fish feed, easier handling, inventory and harvesting of fish, total harvesting, and swift or immediate return on investment and less manpower requirement are the main advantages. The success of cage culture depends on maintaining good water quality around the fish cages. Size and intensity of the process should fit to the size of the water body and water exchange rate. This helps to overcome adverse impacts on water and sediment quality. Accumulation of uneaten feed and fish excreta under the cage can become an environmental problem, but this can be avoided by selecting a site with good water exchange.
பக்கம் சம்பத்தை அந்த இது பக்கத்துக்கு அங்கே வாங்கி அப்படி போஸ்ட் வாங்கி நீ வலையடி சார் ஏன் நெட்டு போடுப்பா அந்த மூளைக்கு இது எப்படி சைஸ்ல 1 கிலோ சைஸ் இருக்கு இன்ச்சூர் முந்துக்கா இது போற பச்சிருக்கா வானா அங்கே போடு
Fishes like carps, catfishes, tilapia, pearl spots, mullets, prawns, snakeheads, pangasius can be reared in cages.
In cages has started in early 19th century, and most of the Southeast Asian countries have developed this technology by about 1950s. This keeping fishes in cages, it has started, first fishermen wanted to hold the fishes for some time in cages, then they thought of growing it in cages. So it has developed and it is commercialized. And the Central Inland Fisheries Research headquartered at Bangalore, Calcutta, they have developed technologies for culturing fishes in cages, culturing fish fries to fingerling stage for stocking of in reservoirs, then also growing the fishes in cages to table size. There is a regional center in Bangalore, and this scientists led by Dr. Krishna Rao and his team, including Mr. Karthikeyan, they have given technical advice to the State Fisheries Department on cage culture. The Karnataka State Fisheries Department, led by its director, Sri H.S. Veerapagoda, with his team of Joint Director Dr. Ramakrishna and Assistant Director of Fisheries Mr. Nagaraj, they have executed a project under National Mission for Protein Supplements in Krishnaraja Sagar Reservoir. And these cages, consisting of Pangasiodon hypothalamus, has been grown into table size and around 70 tons of fishes were grown in these 24 cages. The stocking density was about 40 fishes, around 130 mm per cubic meter, and it has grown about 1 to 1.25 kgs within 8 months. This is a project under national mission, a mission mode project, and this great success was achieved by the hard work of those people involved from State Fisheries Department and a synergistic work culture between a scientific institute of great repute of Central Inland Fisheries Research Institute and the state fisheries officials.
In India, successful rearing of fingerlings and table-sized fish of katla, rohu, common carp, fimbriatus, atropus, pangasius, and silver carp has been demonstrated by CIFRI.
Mass, commonly known as Pangasius, is a native of Mekong River, and this particular species is an excellent candidate species for cage culture for various reasons. The most important is this fish grows very fast. Acceptability for artificial feed is excellent, and this fish is able to withstand stress. And this has export market, especially in the form of fillet. In Krishnaraja Sagar, in 24 cages, the Department of Fisheries has produced enviable around 50 tons of fish in modular cages of 6 meters by 4 meters by 4 meters. The volume of the cage is around 96 cubic meters, and they have stocked based on our recommendation at a stocking density of 40 advanced fingerlings of 13 centimeter size per cubic meter. In other words, per cage they have stocked around 4,000 fingerlings, and they have fed artificial feed, floating artificial extruded pelleted feed, which is having a protein percent of around 30%, and these floating pelleted feeds are given 2 times in a day, and in the beginning fishes were fed at 5% body weight, and later it was reduced to 3%, and in a matter of 6 to 7 months the fish attained about 1 kg. And in the peninsular India, this is Karnataka is the first state where this successful trial of production of Pangasius in cages on a large scale has been done. And the second crop of Pangasius culture is in progress, and the Department of Fisheries, again under the guidance of Central Inland Fisheries Research Institute, they will be culturing another species which is known as Nile tilapia. The scientific name is Oreochromis niloticus. Again, this has an excellent export market in the form of fillet, and the Department of Fisheries will be taking up the culture soon.
In tanks and reservoirs, several fisheries departments have initiated cage culture adopting state-of-the-art technology provided by the Bangalore Center of ICAR-CIFRI under funding from National Mission for Protein Supplements.
Site selection is very important, and as far as this cage culture at KRS is concerned, we surveyed several sites in the reservoir, and ultimately we went in for one site called Meenakshipuram, And that particular site has been selected for various reasons. And one is, even during peak summer, the desired water level will be there so that the cages are submerged sufficiently. And this particular site is free from pollution also. And there is a nearby village where from we can just hire people for logistics, watch and ward, and other things. And finally, this, there is good accessibility in terms of road, etc. Whereas in and around reservoirs, it will be always very difficult to have accessibility. But this Meenakshipuram site is having accessibility, easy accessibility, so that all the things, whatever is required for this cage culture operations and all, can be easily transported to the site.
In Ukai Reservoir, Gujarat, private individuals have taken up CIFRI technology. Pangasius, Nile tilapia, and red tilapia are the popular species. The fish yield from grow-out cages in India has been recorded up to 60 kg per cubic meter.
ಪಂಜರದಲ್ಲಿ ಮೀನು ಸಾಕಾಣಿಕೆ ಮಾಡೋ ಮುಖಾಂತರ ಮೀನು ಉತ್ಪಾದನೆ ಅಂದರೆ ಕಡಿಮೆ ಸ್ಥಳಾವಕಾಶದಲ್ಲಿ ಅಧಿಕ ಮೀನು ಉತ್ಪಾದನೆ, ಇದೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಇದು. ಮತ್ತು ಇದೊಂದು ಕರ್ನಾಟಕ ಸರ್ಕಾರದ ಒಂದು ಹೆಮ್ಮೆ ಯೋಜನೆ. 2012-13 ಸಾಲಿನಲ್ಲಿ ಈ ಯೋಜನೆಯನ್ನು RKVY ಸ್ಕೀಮ್ ನಡಿ ಮತ್ತು ರಾಷ್ಟ್ರೀಯ ಮಿಷನ್ ಅಂದರೆ NMPS ನ್ಯಾಷನಲ್ ಮಿಷನ್ ಫಾರ್ ಪ್ರೋಟೀನ್ ಸಪ್ಲಿಮೆಂಟ್ ಈ ಕಾರ್ಯಕ್ರಮದ ಅಂಗವಾಗಿ ಒಟ್ಟು 334 ಲಕ್ಷ ವೆಚ್ಚದಡಿ ಕಾರ್ಯಕ್ರಮ ಹಮ್ಮಿಕೊಳ್ಳಲಾಯಿತು.
The ICAR-CIFRI is extending technical guidance to various state fisheries departments in selection of reservoirs for cage culture, identification of sites in reservoirs for cage installation, seed stocking, feed management, disease management, harvesting schedule, cage maintenance, etc.
The Central Inland Fisheries Research Institute is the oldest premier research institute in the country, engaged in the R&D activities of the inland open water sector in India. CIFRI has started as a research station in 1947 and it has grown to a big institute in 1959, and in 1967 it came under the administrative control of Indian Council of Agricultural Research. The Bangalore Research Center of CIFRI has its origin as Tang Fisheries Research Unit in Tungabhadra in 1960s, and later it has shifted to Bangalore. This research center was engaged in ecology and biodiversity studies of the country in general and peninsular region in particular. Many stalwarts have worked in this research center of CIFRI Bangalore, and a lot of technologies which are very useful for sustainable production of fish from the inland open water sectors have been developed. The major achievements of this center is the mapping of extensive tank resources in the state of Karnataka, developing protocols for scientific management of reservoirs, induced breeding of Carnatic carps, and also freshwater catfishes, marals, etc. The institute has developed several technologies for conservation of biodiversity in the inland water, open water bodies. This particular research center is also developed foodweb models of reservoir ecosystem for the first time in India. Though this center is catering to the needs of peninsular states in the inland fisheries sector, still a long way to go because of the challenges the country is facing, especially